Problems 14 and 15. The following information applies to questions 14 and 15. A 3 meters long massless rod is free to rotate horizontally about its center. Two 5 kg point objects are originally located at the ends of the rod. They are free to slide on the frictionless rod and are kept from flying off the rod by an inflexible massless rope that connects the two objects. Originally, the system is rotating at 4 radians per second. Assume the system is completely frictionless and ignore any concerns about the instability of the system. Question number 14. Calculate the original tension in the rope. Solution. Tension we can calculate using formula mass multiplied by centripetal acceleration, which is radius multiplied by omega square. So this is the answer. Tension equal mr omega square, which is 120 newtons. That's the answer C. Question number 15. The rope is slowly tightened by a small massless motor attached to one of the objects. It is done in such a way as to pull the two objects closer to the center of the rotating rod. How much work is done by the motor in pulling the two objects from the ends of the rod until they are each 0.5 meters from the center of rotation? Solution. Here we can represent kinetic energy using formula K equal 1/2 I omega square, or this way, 1/2 1 over I multiplied by L square, where L is angular momentum, which is in our case is conserved. So now we can count what is the work done by motor. That's equal to kinetic energy difference between final and the initial position, which is this one. Now let's count what is L, I2 and I1. Angular momentum we can count from initial position, which is in the final position the same. So that's equal to masses multiplied by R1 square multiplied by omega, which is 90 in SI unit system. I2 in second position equal to M multiplied by R2 square, which is 5 over 2. I1 equal to M multiplied by R1 square, which is 45 over 2. And finally we can put these numbers to this expression and get the answer. The work will be equal to 1440 joules, which is answer D. Problem number 16. Shown below is a graph of potential energy as a function of position for a 0.5 kg object. Which of the following statements is not true in the range of from 0 to 6 centimeters? Solution. Let's check all statements. A. The object could be at equilibrium at either x equal 1 centimeter or 3 centimeters. Equilibrium position has a definition for force equal 0. So in a graph it means that slope in this point must be equal 0, which is in 0.1 centimeter and 0.3 centimeters. In point 1 we have unstable equilibrium, and in point 3 we have stable equilibrium. So A is not good. B. The minimum possible total energy for this object in the range is negative 10 joules. That's true. In point 3, we can have object with zero kinetic energy and negative 10 potential energy, which is total negative 10 joules. That's true. C. The magnitude of the force on the object at 4 centimeters is approximately 1000 newtons. Let's check. Here we have slope is 10 divided by 1 centimeter, which is 0.01 meter, and the slope is 1000, which is true. So it means that C is not correct. D. If the total energy of the particle is 0 joules, then the object will have a maximum kinetic energy of 10 joules. That's true. If we have total energy in 0 level, we have a maximum possible kinetic energy in point 3, where we have a minimum potential energy, negative 10. So that will be for kinetic energy 10 joules, which is correct, means that D is not good. E. The magnitude of the acceleration of the object at x equal 2 centimeters is approximately 4 centimeters per second square. Let's count it. We can count what is the acceleration using this formula. Acceleration equal F over m, which is negative delta E over delta x multiplied by 1 over m. In 0.2 centimeters, we can count what is the slope. If we measure it from 1.5 to 2.5, that's approximately 20, and distance is 1 centimeters, which is 0.01 meter, and we multiply it by 1 over 0.5 kilogram, which is 4000 meters per second square, which is not 4 centimeters per second square. It means that this is not correct, and this is the answer for our question E.